In this chapter, we are going to look a little deeper into the internals of Spark. We're going to address a common misconception with the sort transformation that we used in the previous chapter, and that will give us a chance to look at an operation in Spark called coalescing. So in the previous chapter, we built this solution which processes a big data file. Well, all right, it's actually quite a small file that I've given you, but in real life it could be arbitrarily big. It processes that text file and creates a list of the top 10 most important keywords in that file. It's currently working on the subtitles files for our entire set of Docker courses, and they're the keywords. I was crafty actually in that I avoided quite a common trap with the sorting routine. Many people who are new to Spark fall into this trap, and I know I certainly did when I was working with Spark initially, so I wanted to make a whole chapter about this to address this very common trap. So what am I talking about? Will allow me to demonstrate. Just to recap, we've done a lot of transformations here, and then we end with a sorting transformation. And then we finish by taking the first 10 results from that RDD. And because we've already done sort, that's going to take the 10 most popular keywords. But we didn't have to do a take. And in fact, it is very common, as you know now, to do a for each. So I'm just going to reorder this a little bit. In fact, at least temporarily, I'm going to comment out these two lines of code. And I think it will be quite common at this stage to want to have a look at that RDD after we've done a sort. So you know how you might have done that. You might do sorted.foreach, and for each element in that, and for each element in the RDD, we're going to send it to the system.out::println method reference. Or if you prefer, you could do this slightly more longhand by saying for each element, we're going to pass it to the regular method call system.out::println element. Both versions will work just the same. And this is where the common confusion arises, because I think I'm going to find if I run this, it's not going to give me the output that I expect. Now, if you're trying this for yourself, then be aware that it's going to depend on your computer's configuration as to whether you see the same results as me. So don't panic if you get something different, but I reckon if I run this, remember I've printed out the entire RDD, so we're at the end of the RDD here, and at first glance this might look good. We've got some 2s and 1s there. If I scroll all the way to the top, oh dear. Apparently the top answer has a count of 1. And then as I run down these top answers, eventually I get to 857 Docker, which was previously the top answer. And then we've got 127. It looks like we're in order here. That looks, well, it looks correct there. But we seem to suddenly drop down from a 10 to a 9 to a 1. And oh dear, right, okay, well this is actually a total mess. And yeah, we could go all the way down here, and it does seem that these numbers are sort of descending. I mean, they're definitely not random, is my point there. 9, 8, 7, 6, 5, 1. Now it seems to reset to 5, to 1, and, well, whatever. It's definitely not correct. And so, I mean, this is so common because obviously sorting is something that you're going to do pretty much on day one of working with Spark. It's so common, it's a very frequently asked question, and I have found that often people give the wrong answer to this problem. I need to explain why this is happening. By way of explaining, I'm going to start by giving the wrong explanation. And this is the explanation that I have seen in a few places, a few Stack Overflow answers, and Even, dare I say it, a few commercial textbooks on Apache Spark have given this explanation as to why you're not seeing the correct results when doing that sort. Okay, well, the wrong explanation goes something like this. Although we've only touched on this in the introduction chapter, and we will be talking about it a lot in the final chapter, all the time that we've been doing our Spark work, the data in the RDD has been divided into a number of partitions. So the partitions is just a chunk of the data that we're working with, and the idea is that we can either have multiple threads working on the partitions in parallel, or we can distribute the partitions onto separate physical nodes. So I hope that's just revision of what we covered very early on in the course. Now, the wrong explanation goes something like this. We've done a sort transformation on the RDD, and so you might imagine in your head that we have something like this. We have a number of partitions, I don't know how many. There will be a subset of the data on each of the partitions, and all the sort will have done at this point in time is it will have sorted the data on a partition by partition basis. Now remember, this is the wrong explanation. It doesn't work like that at all. But if this explanation were correct, then it would give us a clue as to why things have been going wrong. We've been running the foreach method, and it appears that what's happening is foreach is going through each partition in turn and outputting the contents of each partition. Which, okay, yeah, I can kind of, at first, you can kind of buy that because it does look like, yeah, this could be partition number 1 that we're seeing here. I've actually run this code again since I did the last demo, so it is slightly different. But then you could argue, well, this must be another partition here, and here's another partition there, and we're just seeing each of the partitions output one after the other. Remember, this is the wrong explanation. So the advice that I have seen to solve this problem is, well, of course, what we need to do before we output the results is we have to make sure all of the data is shuffled into a single partition, and then we would see the right answers. I hope I'm being clear here. I'm putting this in place and wrong up here as well, just in case anyone dips into this chapter and sees this slide and thinks, oh, he's a complete idiot, because this really is not what's happening. And you certainly do not need to shuffle all of the data into a single partition in order to get the correct results for a sort. As I say, that is quite common advice. So to carry on with this wrong solution, we could do it. We could do as we've been advised. We could get all of this data combined into a single partition. Now, there is a method to do that in Spark, and it's called coalesce. It actually allows you to specify how many partitions you want to end up with. So if we were to do a coalesce with 1 as the parameter, then Spark would ensure that all of the data is combined into one single partition. And it's true that if we do that and then do a for each, it will fix the problem. Will it? Well, let's try. And let me emphasize again, before I try this, this is not the right thing to do. So we've got our sorted RDD here, and this is where we were doing the printing out, which was coming out in completely the wrong order. So I could now do a sorted equals sorted dot coalesce, specifying I want just one partition. And the theory is now this will fix the problem. Well, let's see. Let's go to the top. And, well, yeah, 857.127.93. And if you've tried it for yourself, have a good look at the output. The output looks correct. And this is why the people who suggest doing this think that this is a good solution to the problem. Calling coalesce, however, was not the right solution for this problem. And if you do what I've just suggested here, then basically you're not really understanding the underlying model of Spark very well. So coming up in the next videos, I will explain what's going on under the hood, why were we seeing the sorting not working properly, and what's the proper solution to the problem.